In this video, we'll use Sohcahtoa to determine the value of a side of a triangle. So the first triangle has a 30-degree angle here. It's a right angle triangle. You can only use Sohcahtoa on a right angle triangle. Alright, 30 degrees here, 49 units of whatever here, and an x. This is the side we're going to solve. So the first thing we do is, compared to our angle, we label what side x is. Compared to 30 degrees, x is on the opposite side of the river, or opposite. This side here is the adjacent. We're not using it, so I'm not going to bother labeling it. This longest side here across from the 90 is the hypotenuse. So we've got to work with opposite and hypotenuse. Looking at the phrase or acronym Sohcahtoa, which one uses opposite over hypotenuse, O and H? The answer is clearly so, or the sine. Well, we're going to do the sine of 30 degrees equals opposite over hypotenuse. So the sine of 30 degrees equals, what's our opposite? That's our x. And what's our hypotenuse? 49. How do you get x by itself? Well, x is being divided by 49, so do the opposite. What's the opposite of divide by 49? Times by 49. When you times both sides by 49, you get x equals 49 times the sine of 30. You could put a times or put a brackets. And now let's solve it. Some calculators don't even need the brackets or the times. I'm going to do it anyway, just in case. So I'm going to do 49 times sine 30. Make sure my calculator's in degrees. Yep. And I get x is nice even 24.5. As in, it's not a big long decimal, so I don't need a rounding dot. I've solved for x. Let's do another one. And this one has x on the bottom side here. Here's a right angle. This time I'm given this side, 35, and this angle is 49. And I want to solve for x. Okay. Same steps, except it'll turn out a little differently, but same strategy. That strategy is look at 49 degrees and compare it to 35. What side is 35? It's opposite. It's on the other side of the river. This long side here across from the 90 is hypotenuse, but not using it, so I'm not going to bother labeling it. This side x here is adjacent, right beside. Adjacent means beside, or touching, but not the hypotenuse, so this is the adjacent side. So we're looking for the formula that uses opposite and adjacent. Looking at the acronym Sohcahtoa, the TOA, or the tan equation, uses opposite over adjacent, so we'll do tan 49 equals opposite over adjacent. Okay, so tan 49 equals, what's the opposite? 35. What's the adjacent? X. Now, tricky for some people. There's actually another video on this of solving when x is in the denominator, so you can watch that if you're going to struggle with this next part here. But in short, when x is in the denominator, to get it out, you've got to times both sides by x. When you do that, times by x, divide by x, this cancels out, which is what we wanted. You get 35 on the right, and x times the tangent of 49. Could have kept the brackets here, but didn't need to. Could have put them there. It's optional. As long as one of them had brackets, I'm happy. So I got my x out of the denominator by timesing both sides by x. Now I just have to get x by itself. X is being times by tan 49. What's the opposite of times? Dividing. So I'm going to divide by tan 49 on both sides. When I do that, the tan 49's cancel, and I'm left with x equals whatever 35 divided by tan 49 is. Let's ask trusty calculator. 35 divided by, I'll put brackets just to make sure my calculator divides by tan 39. Probably don't need it, but some calculators do. And I get, gonna need to round. Let's round to 3 decimals. 43.221. Put a rounding dot because I rounded. And I did it. In both triangles, I used Sohcahtoa to determine the length of a side. Each time, I looked at what sides I had compared to the angle I'm using, and then picked the appropriate ratio based on what sides I had. Opposite and hypotenuse were sine, opposite and adjacent were tangent. I used that formula, and I solved for x.